Good afternoon, class. Here's pre-calculus practice test number 4, module 4, covering chapters 8 and 9 and section 5.4. So here's chapter 8 and section 5.4. Section 5.4, right triangle trigonometry, and chapter 8, part 1, application of trigonometry, the law of sines, the law of cosines, polar equations. We want to find the distance CD, and of course this is a right triangle where this one is 90 degrees. So let's find various angles. This is 90 degrees. These two must add up to 90 degrees. This is 36 degrees. These two must add up to 180 degrees, and so on. So this angle is 180 degrees. So it makes this angle ABD 144 degrees. This is 180 minus 36. And so this is 144 degrees. This angle is 18 degrees because these three angles must add up to 180. So 180 minus the sum of these two gives you 18 degrees. Which means AB must be equal to BD must be equal to 200. Why is that? Well, this is 18 degrees. So is this one. What type of a triangle do we have? It's an isosceles triangle. Therefore, the two sides must be identical. So, the purpose of this question was to find CD. And if you look at this small triangle, which is a right triangle, in other words, a BCD, sine of 30 degrees is the opposite CD over the hypotenuse BD, or CD over 200. Therefore, CD is the product of these two using a calculator and a bunch of decimals, 117.557 feet. That's how you come up with the answer. We want to solve the right triangle. This is 90 degrees. And A is 8, B is 2, C is 90 degrees. Of course, it's clear that C is 90 degrees. So let's throw in A, B, C, D. A is 8, B is 2, C is 90 degrees. And so we can use Pythagorean theorem to find the missing side because two sides are given. A squared plus B squared equals C squared. So 8 squared is 64. Plus 4 is 68. And C is the square root of 68. So 2 squared of 70. Find 8.2. Now, we have all sides. We can use the easy way out. Tangent is the opposite over the adjacent. So for example, so we said this is 2 squared of 17 or 8.24. For example, tan of B is the opposite B over A, 2 over 8 or 1 over 4. So that makes B tan inverse of 1/4 using a calculator. If it's in radian mode, then you have to change it to degrees. And now it's easy to find the last angle because these two are supposed to add up to 90 degrees. So A is 90 minus B. And now we have all sides, all angles. So we write the summary. A is 75.970 degrees, B is 90 degrees, C is 14.03 degrees, and these are the sides. A, B were given, lowercase c is 2 squared of 17. This is the exact answer, and of course, depends how they want you to report that. You do it accordingly, everybody. So it's pretty straightforward. A girl is standing 20 feet in front of the Disneyland Christmas tree. You start at the top of the tree to the bottom of her shoes makes a 60-degree angle. How tall is the tree? What is the distance between the girl and the star? And of course, you have to draw a diagram. Anytime you have applications like this, it's impossible to do it without a diagram because you have to draw a diagram and come up with your variables, define your variables. So here's the star, here's the distance. Again, standing 20 feet in front of the uh, Disneyland Christmas. So that means this is 20 degrees. And it makes a 60-degree angle. They start at the top and the tree to the bottom of it makes a 60-degree angle. So this is 60 degrees. This is 20 degrees. So we want to find the distance C here. Well, this height is X. I'm defining all kinds of variables. So we are ready to move on. Tan of 60 degrees is the opposite X over the adjacent 20 feet, which makes X the product of these two numbers. And it happened to be square root of 3. It's a common arc. So 20 square root of 3 precisely, roughly 34.64 feet is the height. So how tall is the tree? The answer is X equals 34.64. So this part is answer. Now C is the next one we need to answer. And that's A squared plus B squared. So X squared plus 20 squared. And X is found to be 34.64. You put that into a calculator, you take a root, and you get 1600 is precisely 40, but this is almost 1600. Okay, everybody? All right, we are ready to move on. So this is the given. Find AC, the distance AC, angle A and B. And this is 67 degrees. This is side-side angle. We're going to use the sine law, reminding everybody sine law is sine A over A equals sine B over B equals sine C over C. The reason we are using it, because an angle and the opposite side is given, okay? This opposite side is fine. This angle is missing, so you can use this angle versus this opposite side. Okay, I mean the sine of this angle versus this opposite side. Okay, the sine of this angle with this, over this opposite side and find the missing A. So sine of 67 over 8, according to this law, is sine of A over this opposite side, phi. And then cross product, of course, gives you the answer. And then 5, 6 sine of 67 divided by 8 using a calculator gives us a sine inverse of this number. That's, and I'm going to call it case 1 in a moment. I'll tell you why this is the case. And we get 35.1 degrees. So we get this one to be 35.1 degrees. Now, remember, sine is positive in the first and second quadrant. So you subtract this from 180. You subtract this from 180 and you get the second possibility. Let's call this a sub 2 possibility. It's not possible. Why is that? Because if this is the angle and this is the angle, the sum of these two goes beyond 180. It has to be less than 180 so we can find this angle. But the sum of these two is 201.9 degrees. That's why it doesn't work. Again, one more time, there are two possible answers with this inverse, okay? Case 1 can be 35.1 degrees. Case 2 can be 144.9 degrees. This fails because the sum is more than 180. So we have only one case. So what is the missing B? Add these two, subtract it from 180. And these two, 35 and 67, 102.1 degrees, and subtract it from 180. We get 77.9, almost 78 degrees. We have all the angles. We're going to use this known fact with this angle, sine of 77.9, and we try to find AC. Cross product AC is 8 sine 77.9 divided by sine 67. Put it into a calculator. AC becomes 8.5. And now write all of them here. So there you have it. So reminding you, when we solve side-side angle, we end up with several cases. That's why it's called the ambiguous case. Side-side angle, we use the sine law. If and H is B times sine A, if that ends up being, if A is less than that, it has no solution. When A is less than H, which is equal to B sine A, we have no triangle. And if H, which is B sine A, is less than A and A is less than B, then we have two possibilities. Okay, we have this large triangle and this one inside it. This one. This is one of them, and the entire triangle is another. All right, now we are giving A equals 3, B equals 2, A equals 50, draw a diagram. So roughly you throw in the numbers into some oblique triangle. Just make it somewhat reasonable, meaning in this case, B is 2, okay, A is 3, so A is larger than 2, and A is 50 degrees. This is B, this is C, and remember, the larger the side, opposite the larger angle. It should be like that. Now, in case you're making a mistake with your drawing, you can adjust it at the end when you come up with the numbers, okay, and the answers. So following the sine law, okay, we can say sine of 50 degrees over 3, sine of B, sine of B over 2, and sine of a C over C or AB. And this is C, everybody. This is lowercase c, okay? The vertices uppercase. The sides lowercase. It's hard to distinguish between these two. So that's the case. So if we put the first two together, okay, sine B, the cross product results in 2 sine 50 over 3. So sine B becomes 0.511, and B becomes the sine inverse of this number. And sine inverse of this number, when we put it into a calculator, gives us 30.7 degrees. Remember, there are two answers again. The first and the second quadrant, sine has a positive value. Therefore, subtract this from 180. You get almost 150 or 149.3. This would be case 2 if the sum of angles will be working. For it to be working, the sum of these two, A is given, and this one must be less than 180, not even equal to 180. As you can see, the sum of these two, so not possible, because when you add these two, you get 199.3. You have to get a number less than 180. Doesn't work. So that's out. So you have one case. So if you have this one and this one, add them up, subtract it from 180, that gives you the last angle. Okay, so 99.3. So again, This one would be 180 minus the sum of 50 plus 30. That's how we arrive at it, everybody. Okay, so that's pretty straightforward. All right. So now this second part, sine B over 3, sine 50 over 3 is sine C over C. Sine C, we have this angle 99.3. The cross product gives us the C. So C is 3 times sine of 99.3 divided by sine 50. So it's very straightforward, everybody. I hope everybody's fine with that, okay? So we just write all the information now, everybody. All right. We are ready to move on. Draw and solve this triangle A, B, C are given. You have all the sides. When we have three sides, we have to do the cosine. So we do the drawing again. We try to be uh, close to the actual value, but remember, if you're a little bit off, then you can adjust it. The larger the side, the larger the angle opposite that. Okay, for example, A is the largest, then this angle must be the largest angle. So when that happens, you have to go with this formula. Remember, cosine is A squared plus B squared. A squared equals B squared plus C squared minus 2BC cosine A. And as you recall, Pythagorean theorem is a special case of that. And for that, if you solve for cosine A, which is B squared plus C squared minus A squared over 2BC, you can find one of the angles, and then you continue with the next one, and so forth, so on and so forth. So using that formula, plug in B squared plus C squared So we have B squared, which is 16. So this number is 16, everybody, because 4 squared is 16. The denominator is 2 times 3 times 6. 6 times 6, 36. The top 16 and 36 and minus 64. It's minus 12 over 36. And the angle is 121.86 because cosine inverse of that number is a negative number, and cosine inverse ends up being 121.86 degrees. So we have one of the angles. We find the second angle in the same manner. A squared cosine of B is A squared plus C squared minus B squared over 2AC. So we have 64, 36 minus 16. Again, there's a typo here. Oh, okay. I see what I did wrong. My apologies. Let me erase my work. And what happens is this. This is everything else is fine. So this was a mistake, and now it's fixed up. All right. So A squared plus C squared minus B squared. Again, 8 squared is 64 plus C squared 36 minus B squared is 3 squared or 9. So they add up to 91 over 96. And so B is cosine inverse of that number. Putting it into a calculator results in 18.57 degrees. And now add these two, subtract it from 180, and you get the value of C. Okay, it's pretty straightforward, everybody. Let's move on. Try and solve the triangle A is 8, B is C3, and C6. And find the area. Now, we've already done that. We just want to find the area. So I want to remind you, again, this is the second part of the question. Using a formula that has been known for nearly 2000 years ago. It's called Heron's formula, and S is half of the triangle perimeter, semi-perimeter, which is A plus B plus C divided by 2. So the area is square root of S times S minus A times S minus B times S minus C. And therefore, we have to calculate the S by adding them up. So here's what we have. Adding them up. 8 and 3 and 6. 11 and 6, 17 divided by 2 is 8.5. We're going to put this into this formula where S is 8.5, A, B, C are given as follows. Using a calculator, we end up with square root of 58.4375, which is about 7.644. So that's finding the area. All right, I'm going to solve this one. B is 45 degrees, C is 95 degrees, C is 5, and we want to draw a diagram. So we are going to, of course, come up with the third angle first, and then we're going to use the side line in that order. So it's a good practice to have this again. When you put in the numbers, they may not be right at the end, then you adjust the drawing, okay? Because it has to be that the largest side is opposite the largest angle. And so we have those angles. So obviously the last one, just add these two, subtract it from 180. That's the fastest way of coming up with that. And that's 40 degrees. And we write the sine law, sine A over A. So this is 40 degrees. Sine A over A, sine B over B, sine C over C. So we have the following. Sine of 95 over C. The reason we use this because C is the only side which is known. Sine of 40 over A. So just so we know, this is A. This is lowercase b. And cross product results in A being 5 sine 40 over sine of 95. Calculator will result in 3.23. And we're done with this part. Again, we are going to use this side, but this time sine of 45 degrees over B. Cross product, B is the product of 5 sine 45 over sine 95. Putting it into a calculator, and we are done. B is 355, and we write all of it. Again, pretty straightforward, everybody. I like to write this summary. It's up to you if you want to write this or not. This summary has everything. So A is 40 degrees, lowercase a is 3.2, and lowercase b is 3.5. So those are the answers. Okay, we want to solve this triangle. A is 55 degrees, C is 20 degrees, A is equal to 4, and you want to draw a diagram just like before. And these are the two angles given, and 55, 20 degrees, 4. So obviously, we are going to use this one to find the rest of them, and the two angles are given. The missing angle would be 180 minus the 2. That's 105. Using the sine law, sine A over A equals sine B over B equals sine C over C. So sine of 55 over 4 is sine of 105 over, this is B. Cross product. B is, well, let's write the cross product, and then B is 4 sine 105 over sine of 55, which becomes 4.717. So as the number of decimals, just carry as much as possible, and they may ask you how many decimals. Pay attention to that. For the other side, we're going to keep this intact, and now we're going to use sine of 20 over AB, which is lowercase c. And again, the cross product works. And C is 4 sine 55 over sine of 105, which gives you 1.670. And we write all of those just in case. Use the law of cosine to prove cosine A over A, cosine B over B, cosine C over C is A squared plus B squared plus C squared over 2ABC. So we start from one side and we go to the other. So for example, if we start from the left-hand side, we have to take a common denominator, which is ABC. If I take a common denominator, ABC, this one I'm going to multiply by BC, this one I'm going to multiply by AC, this one I'm going to multiply by AB. Now, so, I mean, something like that looks familiar. So let's see what we can do. For example, if we have this as cosine A, we can multiply both sides by BC, see what happens, or even 2BC for that matter. So let's multiply by BC, and basically if I multiply by BC, I get BC cosine A, and I get the right side over 2. If I multiply by 2bc, I get 2bc cosine A, this part, and the numerator only. And I do that with the rest of them also. So bc cosine A is b squared plus c squared minus a squared over 2 instead of 2bc. I'm multiplying by bc. Then also we have cosine, with that being the case, what would be cosine B? Cosine B would be a squared plus c squared minus b squared over 2ac. So let's multiply that one. Maybe I write that. So with that being the case, let's call it that. So using this, then we should know that cosine B must be a squared plus c squared minus b squared over 2ac. And cosine C must be a squared plus b squared minus c squared over 2ab. Okay, one thing that is going to make it, I think, sort of easy to remember. If you go back to this one, if you want a, everything on this side is other than the except cosine. So a squared is b squared plus c squared minus 2bc cosine A. Okay, and from here we get to this one. On the other hand, cosine A is what we didn't use. So b squared and c squared minus squared over 2bc. That should be sort of easy to memorize. So we get this one. If we multiply this one by AC, we get this one. If we multiply this one by AB, put the AB here, we get this one. I need to clean this up. And the reason I'm doing that, because I wanted to calculate this and this and this. That's why. That's why I didn't multiply by 2bc, because the numerator doesn't have a 2 here. Do you follow what I'm saying? And so let me erase this. And so now I'm going to replace this one with this one with this one with that. And because each one has the denominator 2, I can put the denominator here. I hope you understand what happens here. So this one over 2, this one over 2, this one over 2. This one doesn't have a 2, and the 2 comes from the fact I'm dividing by that number. So I hope you see where the number 2 comes from. 2 originally is not there. This is basic math class. So one more time. This one doesn't have a 2. Since they have it, I can put it like. All right. In other words, let me just do this on it. In other words, if you said this one divided by 2, this one divided by 2, this one divided by 2, and you didn't have that, it means absolutely the same thing. I hope everybody following that. So in essence, I'm skipping a step. Or you can say, let me put it another way. Or you can say the whole thing times 1/2. That means the same thing, okay? Because you put the 2 down. Let me erase my work again. And let's say, okay, we have, let's start from the first one, b squared, and then minus b squared. I see c squared and minus c squared. It's a different color now. I see minus a squared and a squared. So what are we left with? A squared plus b squared plus c squared. And that's the right-hand side, and it checks. All right, this is being repeated. An aircraft is spotted by two observers who are 1,000 feet apart. As the airplane passes over the line joining them, each observer take a siding of angle of elevation to the plane as indicated in the figure. So we have 40 degrees and 35 degrees. And this is 1,000 feet. How high is the plane? So we are interested in this distance in essence. So this is the height. This side, we call it y. Let's call this r. P r q is 105 degrees. Y is that? 40 and 35. So PRQ is 180 minus 40 plus 35. And therefore, the angle PRQ must be 105 degrees. Furthermore, if this is 40, this is 50. If this is 35, this is 55. That's another way of thinking about it, okay? Even that will work it out, or the fact that the sum of the interior angles must be 180 makes no difference. There are two ways to see both. And so with that being the case, we are ready to find the value of y. So the sine law says sine A over A equals sine B over B equals sine C over C. Because we have this side 1,000, we are going to use this angle and we want y. By the way, as long as you get y, you can easily find the other one also. So you want to find uh, uh, either one of them and then go to the height because we are interested in finding the height only. So you either find this side or that side. And so to do that, this we said is 105 degrees, right? So sine of 105 over 1,000. If your is sine of 35 over y. This is the sine law. The cross product, y becomes the product of these two divided by sine of 105. Putting it into a calculator results in the value of y, or you can call it PR, y or PR as this value, 593.81 feet. Now you have several ways. The fastest and easiest way would be the tangent of this angle 40 degrees is the opposite h over the hypotenuse y. We are talking about this side, okay, this little angle, this little triangle. And so plug in y and find h by the cross product. If you multiply these two, becomes h. So y times sine of 49 degrees. And it's about 381.69, close to 382 feet. That would be the height of the plane. Two homes are located on the opposite side of a small hill. To measure the distance between them, a surveyor walks a distance of 50 feet from house P to point R, uses the transit to measure angle PRQ, which is found to be 80 degrees, and then walks to house Q, a distance of 60 feet. How far apart are the houses? Okay. We should have this one, everybody. Okay. So this is given. We have two houses on the opposite side of a small hill. Okay. This angle. This is 50 feet. This is 80 degrees. Understanding the concept here. This is 60 degrees. We want to find PQ. So we can use the cosine law because two sides and included angle is given. A squared equals B squared plus C squared minus 2BC cosine A. That means PQ squared equals 50 squared plus 60 squared minus 2 times the product of these two numbers, 50 and 60, cosine of 80. That's the meaning of it. Put it into a calculator, you get PQ squared and then PQ. So PQ squared is 5058.11 and PQ is 71.12 feet, roughly. Two boats that are leaving the harbor in different directions make an angle of 135 degrees. One boat has traveled 300 feet and the second has traveled 350 feet. How far are these boats apart? Draw a diagram. So here's the two. They are going in different directions. We call the corners A, B, C the vertices. This angle between the two is what? 135 degrees. One has traveled 300 feet, one has traveled 350 feet. Which one? Doesn't matter. One of them is 300, one of them is 350. However, this seems to be smaller, so this must be 300. This is larger, so this must be 350. So how far are these boats apart? That means that find BC or opposite A, lowercase a. That's the meaning of it. Again, we have two sides. These are the numbers and the included angle. We are going to go with the cosine law. A squared is B squared plus C squared minus 2BC cosine A. So A squared is 300 squared plus 350 squared minus 2 times the product of these two numbers, 300 and 350. And finally, cosine of 135 degrees. Now, this is the same as cosine of 45 degrees, square root of 2 over 2. However, the second quadrant is negative. I just write that because it's a common arc. You have to put it into calculator eventually, okay? So you calculate a squared, a large number, you take a root, and a is 600.83. Two cars leave an intersection together, traveling on courses with an angle of 45 degrees between them. If each travels 500 feet, how far apart are they? Draw a diagram. So one is going this way, one is going this way, giving rise to an angle of 45 degrees between them, 500 feet each one. This is the missing side. So clearly we're going to use the cosine law. A squared equals b squared plus c squared minus 2bc cosine A, and or c squared equals a squared plus b squared minus 2ab cosine theta. Either way, uh, depending upon how you find it, cosine theta, cosine A, you name it. Needless to say, it means 500 squared plus 500 squared minus 2 times the two numbers 500 and 500, cosine of 45 degrees. You have to put it into a calculator, do the math, take a root. So I'm going to give you the final answer. The C, or the question mark, is 382.68 feet. Two cars leave an intersection together, traveling on courses with an angle of 30 degrees between them. If one travels 1,000 feet, the other one 720 feet. Now, how far apart are they? Draw a diagram. So one is going this way, one is going that way, making a 30-degree angles in between. One of them is covering 720 feet, one of them is covering 1,000 feet. So what's the distance between the two? We have no idea. We are going to use cosine law. In essence, the extended Pythagorean theorem. So 1,000 squared plus 720 squared minus 2 times the product of these two numbers, cosine of 30 degrees. That's the answer for c squared. You find it, you take a root, c becomes 520.89, almost 521 feet. Again, you have to put this into a calculator, get the c squared, and then eventually get to c. George is standing 35 feet in front of a house and notices that the angle of elevation from eye level to the top of the house is 60 degrees. Find the height of the house, draw a diagram. Reminding you of the angle of elevation, basically this is a horizontal plane, horizontal side. If you look up to find the object, this is the angle of elevation. If you look down, this is the angle of depression. So in a matter of comparison to horizontal line or horizontal plane is called. And so in this case, we are looking at this angle being 60 degrees. This distance being 35 feet, and height is a question mark. So tan of 60 is the opposite h over the adjacent 35. That is the fastest way to go. H is the product of these two numbers. Put it into a calculator, and we get 60.62. By the way, note the height of the person. In this case, George is not given, so that means this is the bottom of the house anyways. Otherwise, they would give it to you, and then the height will be added to h in case if the house is down here. Okay. George is standing 27 feet in front of a house on a hill and notices that the angle of depression from eye level, the top of the house to its bottom, is 73 degrees. Find the height of the house. Draw a diagram, again reminding you of this concept. And so, standing at top of the hill. So this is top of the house, and this is the bottom of the house. So we are interested in this height, and this is the angle of depression. This is the horizontal. And so this angle is 73 degrees. This distance is 27 feet, and this height is missing, everybody. Again, the same thing. Tan of 73 degrees is the opposite height over the adjacent 27 feet. The same concept. So h is the product of these two numbers. Put it into a calculator, gives us the height of 88.31 feet. So the height is 88.31 feet. Remember that when you have two lines, two parallel lines, A, B, and C, D, and there is a line that crosses both called transversal line, GH, it creates several angles. The figure shows two parallel lines, A, B, and C, D, intersects by the transversal line, GH. Corresponding angles are equal if the transversal intersect at least two parallel lines. So you can see all the angles that are equal. Just reminding you, corresponding interior angles, corresponding exterior angles. The pairs of corresponding angles in the given figures having the same color are numbers 1, 5, 3, 7, 4, 8, 2, 6. In the given figure, of course, AB is parallel to CD. That's angle 1 is equal to angle 5. Number 3 is 7, 4 is 8, 2 is 6. Okay, just to remind you of what we should know. Alternate interior angles are equal. That means 4 and 6 are equal, called alternate interior angles. 3 and 5 are equal. 3 and 4 add up to 180. 6 and 7, they add up to 180. 1 and 2, they add up to 180. 7 and 8, they add up to 180 degrees. So same side interior angles are supplementary. Remember, supplementary means they add up to 180 degrees. So for example, 4 and 5. So 4 and 1, they add up to 180 degrees. 4 and 5, they add up to 180 degrees. Alternate exterior angles are equal, like 2 and 8. . 1 and 7. Same side, exterior angles are supplementary. 1 and 8. 2 and 7. So there's a lot of information here. When you have two parallel lines and a line crossing both, you should know which angles are equal, which are not. Okay, so hopefully we are very comfortable with that. A balloon is flying at a height of 600 feet, directly above the Statue of Liberty. What is the angle of depression from the balloon to some airport that is 5 miles from the Statue of Liberty? Draw a diagram and bear in mind 1 mile is 5,280 feet. We should know that when we deal with units, they have to be the same. So here's a balloon, okay, at top of the Statue of Liberty, 600 feet above it. There is an airport 5 miles away. This is the angle of depression which is equal to this angle. We just went over these two lines being parallel and a line cutting the two, crossing. So alternate interior angles. So this angle, tan of theta is the opposite 600 over the adjacent 5 miles. So this is the same as theta. Okay, alternate interior angles are equal, as it was mentioned. So tan of theta is 600 feet over 5 miles. We are going to change either this one 2 feet or this one 2 miles. It's easier to change this by multiplying by 50 to 80. So now both of them are in feet, everybody. And that's the idea. They must be using the same units, everybody. Must be using the same units. Putting it into a calculator results in this number, and you want to use many decimals to be on the safe side, 0.0227272, just for the sake of argument. If you use one decimal, that actually becomes 0 because next to this 2, it doesn't change. Okay, so many decimals. So what is theta tan inverse of this number? Put it into a calculator. It gives you 1.302 degrees. That's the case. A rocket takes off at a bearing of north 30 degrees east. After flying for 900 meters, the pilot turns 90 degrees and heads northwest. After flying for 1,000 meters, what is the new bearing of the plane? Draw a diagram. Reminding everyone that one way to look at the bearing, you just look at the either north or south, and then you mention east or west, and the angle in between. So for example, this one is north 30 degrees east. This one would be north 70 degrees west. This one would be south 50 degrees west. This one would be south. We mentioned north or south first, then the angle 20 degrees, and it has to be acute angle between 0 and 90. And the side, it's either east or west. In this case, is east. So south 20 degrees east. So first, reminding everyone of that. So what's happening? So we have this. And so a rocket is going north 30 degrees east this way. So north 30 degrees east is this way. This is the angle. Makes a 30-degree angles with the north, 60-degree angles with the east, just for the sake of argument. So this is going this way. Okay. So it goes for how far? 900 feet. Then turns 90 degrees. When it turns 90 degrees, either this way or the bottom. It's north west, so it goes this way. So first we are going this way. For how much? 900 meters. Then we go this way. We make a 90-degree angle here, everybody. And we go for 1,000 meters. Now, what is our new bearing? Well, first let's do the drawing. That means let's connect these two. So the bearing north, west. What is the angle in between? So when we find this angle, we're going to say north, that angle going west. So first and foremost, this angle is alpha, let's say. So we are going north, alpha, west. The idea is that we have to find alpha. So we know this is 30 degrees, right? This entire angle we don't know, but we know this one is 30 degrees. If we find theta, theta minus 30 is alpha. So I'm explaining the methodology we're going to use. So we know this is 30 degrees. We don't know this angle, but we do know that if we find that angle and subtract 30 from it, we get the alpha that we want. That's all we're looking for. So in this triangle, we can find theta because we have two sides. So tan of theta is the opposite 1,000 over the adjacent 900. Both of them are in meters. They cancel each other, so we don't have to worry about the units. The units must be identical. Both of them are in meters, everybody. So 10 over 9. So theta is tan inverse of 10 over 9. Putting it into a calculator result in 48.01 degrees. So that's theta. This is the entire blue angle. Subtract 30 from it. 18.01 degrees. So put it here and you're done. So the answer is north, 18.01 degrees west. That's the new bearing. An aircraft leaves an airport from a runway with a bearing of north 40 degrees east. So north east, so 40 degrees here. So make a 40-degree angle, go this way. After half a mile, we go for half a mile, the pilot turns 90 degrees. So when we turn 90 degrees, either this way or that way, that creates a 90-degree angle. And heads towards the southeast, so this way. After flying for 1 mile in this direction, what bearing should the control tower use to locate aircraft? Draw a diagram. So again, north 40 degrees east. So we do the drawing here this way. It goes for half a mile and we have a 40 degrees. Then we make a 90-degree angle going for 1 mile. What bearing? Let's connect the two. And the bearing now is south going this way, which is east. So we need the angle in between and we are fine if we find it. Therefore, if we have this angle, This is the angle we need. We're going to call it alpha, and we're going to say the answer is north alpha east. Now the question is, how do we find alpha? That's what we're going to look at, okay? Well, we can find this angle that we are going to call it theta, and this angle, and this angle, they add up to 180 degrees. This angle, 40 degrees, and theta and alpha, plus 40. Theta and alpha, they add up to 180 degrees. 40 degrees plus theta plus alpha, they add up to 180. So all we have to do, find one of them, we can find the other one. So we can find theta, and then alpha is known. Again, theta is easy to find using this triangle. Tan of theta is the opposite 1 mile over the adjacent half a mile, which makes it 2. And theta is tan inverse of 2. Using a calculator, 63.43 degrees. And alpha is 180 minus the sum of 40 and 63.43, resulting in 76.57. And the answer is south, 76.57 degrees east.